think it's okay now. Okay, so this is the linear regression line, and let's say this is an entry, and there are many others, right? But I want to focus on one of them. So for this particular x value, let's say this is 100. And I'm going back to the data set to explain on a number. So for 100, I have 257. This is our point. I selected the point x being 100 and y being 257. But basically, this is what the line will give us. This is what it's called the predicted value. Predicted. This is the height right here for the predicted. So if there is no error, then the predicted and the actual point should be the same, right? So this is what is called the y value, the exact y value that I got from the point. And this is the predicted value. And the notation for the predicted value is y hat. Of course, this is the actual value for 100, and this is the predicted value for 100. What will be the error? Also called residual. It's always y that is the exact y value minus the predicted. How do I know how much is the error for this particular point? Well, I have to go back. Where's my line? Somewhere I have the line right here. In here, I'm going to plug in 100, but I don't have to do it here because I have the line in y1. So y1 already has the information stored. I don't have to put it in by hand because I already stored it. So I go to second in table, and I want to plug in 100. And when I plug in 100, the predicted value it was, so I found 260.81. So, okay, in this case, 257 has to be here. Sorry, my apologies. I mean, I should have determined the predicted first. So this is the 257. It happened for that point that the predicted was above. That's okay. It can be above or below. It doesn't matter. The residuals can be positive or negative. It doesn't matter. Okay, so then the residual or the error for x equals 100 will be the exact value, 257, minus the predicted value, 260.81. And that will be a negative number. So let's see what we get. I'm lazy, so I'm going to do this with a graphing calculator. I shouldn't be doing it. It's negative 3.81. So negative 3.81. That's the error. And I put all the information for you here. So this is yi, this y predicted is y hat, and the residuals for any y value will be the value, the actual reading minus the predicted. And the residuals can be positive or negative. So then, now we know that the notation, the correct notation is that y hat, and where is my information? Right here, 3.166102x minus 55.7966. So this is the linear or the least squares regression line. And I also put the calculation how we can determine these coefficients, and we can do that. So the general form is y1. It's denoted by b1 and b0. So this is the slope. We normally know this, right? mx plus b. This is the slope, and this is the y-intercept. But this is what we know from algebra. And how do we determine the slope, and how do we determine the y-intercept? The slope, b1, is the correlation coefficient multiplied by a fraction of the standard deviation for y over the standard deviation for x. And the y-intercept, all these formulas will be given to you, is the mean for y minus b1 times the mean for x. Since we already have the numbers, let's calculate with the formulas now because we have everything. So let's calculate b1. So we have the correlation coefficient 0.9386958 multiplied by the standard deviation for y. Some pages ago I had the standard deviation for y. Here it is in the table. Standard deviation for y was 7.7414. Standard deviation for x was 2.2952. StatCrunch will give us much better results, but because we rounded here, we truncated, we rounded up or down. So let's see, we have to get very close to 3.166102. So let's see, 0.9386958. Let me see if I put all the digits. Yes. Multiplied by 7.7414 and then divided by 2.2952, and I get 3.16609. Of course, there must be some tiny error somewhere. So B1, 3.1660943. And now for B0, I will multiply this number. I will put negative the previous answer. I will multiply by x bar. X bar, where are you, x bar? I lost my x bar. Here it is. X bar 101.875, and then add y bar 266.75. I have to be as close as possible to this. It may not be 100%. It's negative 55.7958 versus 66. So very close. So this is the way we calculate. I'm just copying what I got. 79585809. So now let's go back to StatCrunch for a moment because I want to plug in 100 and see if we get what I came up with. Where was it was 260. Yes. So let's put in StatCrunch a particular error that we would like to determine. So for example, put 100 and let's see if we get this. We have to, because we use the least squares line. Okay, I'm going to share my screen. So now we can look at StatCrunch. Where I use StatCrunch, I guess here. And nope, yep, here. So I'm going to go back. Here it is. I have to go back to the data set. So let's go to stat, regression, simple linear. I'm selecting the variable again. It's club head. I want the y to be the distance. And prediction. I want to predict, where's my keyboard? Okay, I want to predict for 100. Okay, so again, same thing. I want a fitted line, that's fine. I will omit this for now. I just wanted to show you how to put it in. And let's see what we get. Okay, here it is for 100. It gave us 260.81 And from our calculations, we got 260.81 and they got 260.81356. Of course, much better approximation than what we did. Any questions? Any questions? Any questions on how to determine? And here it is. Finally, here is the regression line. It tells you that this is the slope, 3.16 times the club head, and then minus the y-intercept, negative 55.79661. So you have that. You have the y-intercept, you have the slope explained again. What else we have here? And the predicted that we selected. And there are other things that we are not ready to read yet. And of course, the correlation coefficient right here. Any questions? I'm going to stop sharing. Any questions? Okay, so let's see if there is anything else. If not, I have a quick quiz for you. So we can also compute the sum of the squared residuals for the data. So we can do that. So we can compute the sum of residuals, sum of squared residuals. There will be the sum from I equals 1 through 8 from yi minus yi hat squared. Sum of the squared residuals. So how do we determine that? We can determine with the graphing calculator. So in stats, I cannot, maybe it will allow me to invent another. Yep, okay. So what we will do is we will subtract, so in parentheses, my y data is in L11. I subtract. I have to create this. I haven't created this yet. So I'm gonna, we have to, yeah, I know. So I have to create another, and it's not gonna allow me to. Okay, so I have to, why isn't it allowing me to? Okay, now it does. So I have to get rid of any one of my data sets. So I'm gonna get rid of L9 and I'm gonna clear L9. So I need to determine yi for all the entries and I haven't determined them. So highlight the top of the list and just call variable y1 and plug in list L10 in my case. So no, not that, I didn't mean that. Okay, so I want list L10, so I want the variable y1, yes, and I want to plug in, let me select my list. Yes, it does select my list. Allow me to. Okay, here it is. Now I want all these, so better. Okay, so I have y1. I have the predicted. So now the predicted, in my case, they are in L9. And y1 in L11 for me. So now I'm going to delete that. And I'm going to determine left parenthesis L11 for me minus L9, close the parenthesis, and I'm going to square them. I got all of them now, but they are squared, and why did I get a negative number? L11. I am not sure I pressed the square button, so I'm going to redo this. Left parenthesis, L11. Yes, that's the data set. I subtract. I think I didn't put the square. I cannot have negative numbers.
That's my fault. I wasn't paying attention.
Okay, yes, thank you so much. I really appreciate that, Sean. Yes, minus L9, close the parenthesis, squared, and enter. Ah, I'm happy now. In L10, I'm going to find a sum with one variable stats. Stat, and I want L10, yes, L10, calculate for me. I only want the sum, 49.8576. So that's the sum of all the error squared. So the difference between the real number and the predicted through the linear regression. All of them squared and all of them summed up. Okay, we have 10 minutes. Let's see if we can look at that quiz. That's all I had to say today.